Hi everyone, welcome to the Earth Science Regents Review podcast series created by the Hommocks Middle School Earth Science Department. Today we're going to be talking about Earth's rotation. First off, you just need to know what rotation is. Okay, it's going to give us day and night. Okay, it's going to be the spin on our axis. The Earth is going to be tilted at approximately 23.5 degrees on its axis, and it's going to rotate once every 24 hours. You don't get that mixed up with revolution, which can give us our seasons, we revolve once every 365 days around the sun. So you can see the rotation here. This animation is actually tilted on a 23.5 degree axis, but the rotation in a counterclockwise direction is going to cause everything to rise in the east and set in the west. That's rotation. Now star trails are going to help support the idea that the Earth rotates and we're not stationary. Stars are going to move across the nighttime sky, not because they're moving, but because we're moving. So that's a motion in which we call apparent motion of the stars. So if we had a chance to look north, stars would make circles around Polaris. They would rise in the east. They would appear for a very short time in the south. And they would set in the west. So star trails help support the idea that we're moving, not the stars. The stars are going to be fixed in the nighttime sky. So there are some characteristics you do need to know about rotation. We are going to rotate west to east, which means that the sun, the stars, they're all going to rise east to west because we're rotating in a counterclockwise direction. We rotate at the magical number of 15 degrees per hour. Stars are going to rise in the east and set in the west, okay, including our own sun, which is our closest star. It's going to be in a counterclockwise rotation in the same direction as we revolve as well. We revolve counterclockwise around the sun. And again, the characteristic motion of the stars, called apparent motion, are going to help support the idea that we rotate, that we're actually moving. So you can see the path of the sun. It's actually the path of the sun on December 21st. East is going to be on your left, west is going to be on your right, which means that we're looking in a southerly direction here. And you can see the apparent path of the sun. The sun's actually not moving across the sky. It's appearing to move because we're the ones that are rotating. And again, you see the apparent motion of the stars, okay, rising east, setting west. Okay, in this animation, we're actually looking south. You see how the sun's rising east, and will continue and set in the west. This is what we call the apparent motion of the sun, apparent motion of the stars. All your stars are moving across the sky because we're the ones that are rotating, which helps support the idea that we are not stationary in the solar system. Okay, so there's a couple pieces of evidence that we use to help support the idea that we rotate. We already talked about star trails. Star trails help support the idea. But there's actually two pieces of evidence that scientists have discovered that help support the idea that we rotate. Okay, it's called the Coriolis effect and the Foucault pendulum. Those are going to be the two pieces of information that we talked about in class that help support the idea that the Earth rotates. The Coriolis effect is going to be important here because anything fluid meaning anything air or anything water, so such as our air currents and water currents, are going to be deflected due to our rotation of the Earth. So in the northern hemisphere, everything is deflected to the right, and in the southern hemisphere, everything is going to be deflected to the south. So you can see with the cannon here, you see the expected path of the cannonball and the actual path of the cannonball. In the northern hemisphere, it's a deflection to the right. You always look in the direction of the arrow. And in the southern hemisphere, it's a deflection to our left. Again, you want to look in the direction of the arrow. So the Coriolis effect is going to help support the idea that Earth rotates. If the Earth didn't rotate, those cannonballs would go directly to the North Pole and directly to the South Pole, but that's not the case. The second one is what we call the Foucault pendulum. And basically, this is a pendulum that's going to swing exactly north-south. And what's going to happen is over the course of time, the Earth is going to rotate underneath the swinging pendulum. Most of the time, these pendulums are going to have pegs set up in a circular pattern. Most of the time, going to be about 15 degrees apart because the Earth rotates 15 degrees per every hour. And every hour that goes by, the pendulum will knock over 2 pegs per hour, one on the upswing, one on the backswing. Over a 24-hour period, all the pegs will get knocked down, very simply because the pendulum stays north-south while the Earth rotates underneath it. So that's essentially what this setup would look like with a Foucault pendulum. That's it for now. Those are some of the ideas about how the Earth rotates. Good luck on your exam, and we'll talk to you soon. Bye-bye.